Okay, so here we have my old reactor design, except it's been a little improved. We've got heat transfer pipes all the way through down to 2 medium turbines. You can check the power levels here. You've got a Geiger counter and a dosimeter. But we've got the display that shows the control rods, which are attached to hotkeys. So now we can see that all the control rods are in, all the control rods are out. You can do it in a lot of different manners. Oh shit. Oh, forgot about the proper. So, yeah, 8 and 9 are also attached to the same key bindings that my controller are, so that's not very helpful. But then these ones are quite simple, so we can see 1, 2, 3 and 4 from the top, so we can just press 1, 2, 3, 4 on the keyboard, and all the reactor rods are in. No, all the reactor rods are out actually. Push them all in a little tap. So this is the old design. We've got an industrial elevator over here, powered by 2 of these pulley systems, which we also used for the refueling station. We've got blast doors up here. When it's completely finished, you'll be able to rally things up and down in the elevator into here, maybe to refuel or whatever. We've got like a control room down here, stuff, another blast door, 2 more floors, and then I'll put this up in the workshop eventually. We've also got some other stuff up here, like some basic stuff. So we've got got a Geiger counter, dosimeter, temperature, decay meter, and isotope tester. But this is in the old design, which I've kind of given up on now, because what I have is a new design, which is circular. And as we can see here, it's already going. For some reason I'm not. Oh, I know why. It's because I used the same hotkeys for this thing, but that's alright. Because what I do have is emergency cooling. I also have built in 2 medium turbines again for power generation. And so the way that this one works, because it's circular, is we've got these 2 what I call main control rod things, because you can see we have 4 individual pieces on each side, and then when we pull these all the way out, we can see, if we push this one all the way in, we can see that the reactivity is mostly on this side, whereas if we switch the role, we can see that it's mostly on this side. So if this one goes out, then these reactor rods get hot, but there isn't a specific part of the core that can be hotter than another, because we've got heat transfer pipes which throw it all the way through, and this is basically the core of the core. We've got our inner section here, which is the core, and then we've got the structural parts around it, which are mainly just hold it in place. Now you see, this structural piece is the only thing that's holding this core up, and this structural piece is all attached to this concrete. So if this concrete were to be broken for whatever reason, then, well, let's see what happens, because I've built in a little safety feature up at the top. Because as you can see here, once the concrete has successfully exploded, we can see that the structural piece isn't actually attached by anything, but it catches on this little piece of the roof. We can see, well, we could see, things on currently, that the core would still be stable. You can still use the core, it's just not attached to anything anymore. It doesn't touch the ground, although it may possibly mess with wires, like the destructible wires that I might use for the turbines. But as of right now, the way to operate this would be simply to pull off all of the sort of control rod assemblies, just wait for it to get white hot. We don't want to start the turbines immediately, we want to wait until we get, let's say, I don't know, get a temperature reader, then we'll see from there. Thermometer. So, pop it on. We can see, once we get to about 1000 degrees, I'd say. Now that we've got to 1000 degrees, we're going to get rid of this thermometer. Then we're going to activate the heat valves, which, as we can see, is going to cool down the core a lot, because a lot of this thermal energy is going to be sent straight through. And then from there we can control the core by perhaps maybe doing this. Now this lowers reactivity all around the core, and even if you can see that there is still a minor amount of reactivity everywhere, so to fully shut down the core, you sort of enclose it within the reactor rods, and then if there is an emergency where you need to cool down, you can press the emergency turbine coolers, whatever you want to call them. And as we can see, this doesn't actually cool down the turbines, but the heat transfer pipes, this being cool and then this being cool, does eventually turn off the things. But you can also turn them off right there with the heat transfer pipes. As we can see here, we've got specific things for heat 1, heat 2, and then we can see we've got obviously the display to show the pistons in the core itself. These haven't been linked up yet, but these will eventually link up to the fans. We've of course got our, what's it called? Geiger counter up here to make sure that if there were an explosion, we would know. Well, we would quite obviously fucking know if there was an explosion, but regardless. As well, we have water instead of graphite in the old reactor, water moderators, because I find it to be better. And instead of using LE235, we're using HU235, which is slightly more fissile than the other one. And hotter as well. But the only way that this core could really melt down, I'm going to show you what happens when it does, is if you pull all of them out and then just don't turn on the heat transfer pipes, because these seem to keep it cool. But it needs to get to about 8,000 degrees to, of course, explode. So stick them on there. The easiest way to do this would be to do something that couldn't really be done, which is get rid of the control rods completely, which is a bad idea enough on its own, because now as we can see the temperature is rising quite quickly. Also the radiation is quite severe, although it hasn't been detected on a Geiger counter yet. We can see that the temperature is however going up too fast, and we would not be able to stop it from blowing up. And when it has blown up, what happens is that probably ought to make way for this one to attack. First of all, I'm going to turn off that really annoying buzzing sound because that is getting on my nerves. But as we can see, we've obviously got the core inside of structural pieces. We've got the roof that was originally on top, and we also have the 4 pieces that used to go on the outside of the structure of the core. Now, what you're going to notice is that everything that's outside here was originally outside here. These are control rods, these were inside. All the pistons are still inside. All these bulletproof shielding that we used for guide rails for the reactor rods, they were all still inside. And I find that to be quite interesting. So I'll upload those 2 things into the workshop, and then I will put their links into the comments below. Thank you.